Question number 5, we have here a circle has equation. This is the circle equation given. A line with the equation y equals to x minus 9 intersect the circle at point A and B. So that means we have a circle like this, and there is a line AB that intersects the circle at point AB. So find the coordinates of 2 points of intersection. So we are just going to put the value of y from here to this equation of the circle. So let me rewrite this equation of the circle, which is x minus 1 squared plus y plus 4 squared equals to 40, and we have here y is equal to x, from here x minus 9, y is x minus 9. So let's substitute that value here. This will become x minus 1 squared plus y is now x minus 9 plus 4 and squared equals to 40. So let's rewrite this one. So this is going to be x minus 1 squared plus x, this is 9 minus 4, that is 5, is negative because 9 is negative here. So and then squared equals to 40. Now let's expand these brackets. When you expand, we are going to use the formula of a minus b whole square, which is equal to a squared minus 2ab plus b squared, right? So using this, we will have here this is x squared minus 2x plus 1. Then we have plus here a square is x, now x is a, minus 5 times 2 10 x plus 25, and I'm bringing 40 on the left hand side, minus 40 equals to 0, right? So now combine the like term, x squared and x squared, that is 2x squared. Then we have 10 term of x here, negative 12x, and then this is 25 plus 1 26 minus 40, which is negative 14 equals to 0. Now we can divide the whole equation by 2. So that equation will then become, after dividing 2 by 2, it is x squared minus 6x minus 7 equals to 0. Now let's factorize that one. So x squared minus 7x plus x minus 7 equals to 0. So x is common, so x minus 7, then negative 1 common, x minus 7 equals to 0. So from here we have x minus 7 into x minus 1 equals to 0. So now from here we have either x minus 7 is 0, or we have x minus 1 equals to 0. That gives us x equals to 7 or x equals to 1, right? So we have this value of x equals to 1 and 7. Sorry guys, here it was minus, this was plus 1 here, so we are going to take plus common here, so this will make it plus 1 here. So x is negative 1, right? So x is negative 1, and so for this value of x we can take the value of y, that will give us the coordinates of a and b. So now our y is equal to x minus 9, right? So from here we are going to substitute the value of x as 7. So when x is 7, then y is equal to 7 minus 9, that is negative 2. So we got the point here, coordinate 7 and negative 2, right? And another one, when we have x as negative 1, then y minus equals to 7 minus sorry, x is now negative 1. Oh, wait, now when we have x as negative 1, then this is going to become minus 1 minus 9, that is minus 10. So second point we have here negative 1 and negative 10, the values. So these are the coordinates of 2 points of intersections here at A and B, right? So one answer is this one here, the another one is here. right? Now find an equation of the circle with diameter AB. So with diameter AB, now if let's say we have this the same circle we have here, but AB is now a diameter, so it is passing through the center here. So this is now A and this is now B. So we have the coordinates of A and B. So coordinate of A that we did in the first part here, we have this 7, -1 and -1, -10. So I'm rewriting here. A is now 7 and -2 and B is -1 and -10, right? So to find the equation of the diameter, we must have the center. So for the center, as AB is a diameter, so center is going to be half of this. So this is going to be 7 -1, the midpoint of this, -2 -10 over 2. So this is as 3 and -6. So this is our center now. So now the equation of the circle is x minus a squared plus y minus b squared equals to r squared. So we also need r here. So r we can calculate from here by the distance formula. So coordinates of a and b we have here. This is a, this is b, and coordinates of a, r is going to be 7 minus sorry, let me take the, we can use the distance formula for to find out the value of r. R square is going to be x2 minus x1, that is 7 minus radius of this is going to be 7 minus 1, 7 minus from here, x2 minus x1 squared, y2 minus y1 squared. X2 minus x1 is here 7 minus, it is going to be 3, minus 3 squared, we have to take this one here, c, coordinates of c, which is 3 and 6. Let me write here, then it will be easier. So a we have here 7 and -2. We are looking for this distance a to c, 7 minus 3, then plus we have -2 and -6, that will become +6 and squared. So this is 7 minus 3, 4 squared is 16, plus then we have here this is 6 minus 2, 4 16 again. So this is 32, so r is square root of 30. R square is 32 and r will be square root of 32. So we are going to substitute these values here. We have a and b. A and b is, here is the point of center, which is x minus now 3 squared plus y minus, there is a minus here, so this will become 6 squared equals to 32. So this is the equation of the circle that we are looking for, right? You can leave your answer here only. Now let's see next question. We have question number 6 here. You can see the diagram shows the sector OAB of a circle with center O and the radius r. The angle AOB is theta radian. So we have this angle here. It's given that the length of the arc is 9.6 and the area of the sector is 76.8 centimeter square. Find the shaded area. So let's see what we are given here. So we have here length of arc AB. So this length of arc AB, so let me rewrite here. Length of arc AB, this is given to us as 9.6 centimeters, right? Length of arc formula is r theta is equal to 9.6 centimeter, but we do not have r, we don't have theta, so we are just leaving it like that here. Another thing, what is given to us, area of the sector. So area of sector is 76.8 centimeter squared, right? So the formula of area of square is half r square theta is equal to 76.8 centimeter squared. So when you multiply this 2 over here, this will become r square theta. 76.8 times 2, that will give you 153.6, right? So from here, it's easily we can write it down r into r theta. Is that okay? I guess you understood. What I did, I just written have this r as r times r. So r theta we can get the value from here, from equation number 1. So r into r theta is now, from here we are substituting 9.6 centimeter equals to 153.6. So from here we can find out r. So r is going to be 153.6 divided by 9.6. So this gives us 16 centimeter. So we got r as 16 centimeter. So radius is now 16 centimeter here. So we have this is 16 centimeter, and this will also be 16 centimeter, right? So that if we got the value of r here, then we can find from here, this can be r is 16 times theta equals to 9.6 centimeters, right? So from here we can find out theta. So theta is 9.6 divided by 16 divided by 16. So this gives us 0.6 radian. Remember that angle is in radian, so theta is 0.6 radian. So now we can find out the value of shaded area. So area of shaded region, is going to be area of sector minus area of triangle. Let me show you. From here we are looking for this one here. If I see, so we are looking for this shaded part. So this triangle from here to here, so from here we have this triangle, this is the sector minus area of this triangle. Now to find out area of this triangle, we can find out area of triangle will be half AB sine theta, right? We will use the formula here, half, and A is 16, B is 16, sine theta we already got it. Sine theta is 0.6 degrees, right? 0.6 radians. So when you calculate this is equal to 72 point. You just substitute the values. This comes out to be 72.27 centimeters squared, right? So this is area of this triangle here. So then we can substitute these values here. Area of sector, we are given this one 76.8 minus area of the triangle we have just calculated 72.24. So this comes out to be when you do this calculation 4.5223. So approximately 2-3 significant figures is 4.53 centimeter squares, right? So this is how you can calculate the shaded area of this sector. And now find the perimeter of the shaded region. So for the perimeter, let me just draw that diagram here, so to make it clear. It's like this, right? So this we have area here, we are the radius we have this 16 centimeter, and this, if I draw it like a line, if I draw in the middle, so this triangle is going to become a right angle triangle, and we have this total angle was 0.6. So this was 0.6, and then this smaller angle will become half of that, that is 0.3 radians, right? So as theta was 0.6 radians, so half of that is going to be 0.3 radians, right? So now we can use this the we are looking for the perimeter of the shaded region. So for that we need this length of AB actually. That's why we are doing this. We need this length, right? So if we find out this AM in the middle, then we will do the twice of that to find out the length of AB. Okay, so now I'm using this smaller triangle here. Let's say this is AOM. In triangle AOM, we have this one here. This is we have theta, and we have this one hypotenuse, and we can find out AM. So this we are going to use sine. So cut over here. So I'm using opposite over hypotenuse. Opposite here is, let me rewrite here, sine 0.3 equals to opposite. Opposite is AM. So AM over adjust hypotenuse. Hypotenuse is 16 now. So this is going to be 16. So from here I have AM is equal to 16 sine 0.3. So when you calculate this, just plug in the values in calculator. So this is okay, let's just put AB. AB is going to be 2 times AM. Okay, so 2 times AM, that is 16. So we can do everything together. So this is 9.457 centimeters, right? So now what will be the perimeter? So perimeter that we are looking for is length of AB, which is 9.457, and length of the arc we already have 9.6 here. If you see, length of arc is 9.6 here, so plus 9.6, so this comes out to be 19.06, so approximately 19.1 centimeters to 3 significant, right?